been working in the space of algorithmic fairness and machine learning. And he'll be talking with us about tracking and improving information in the service of fairness. Thanks, Michael.
Good. Okay, great. We on? Great. So, thank you, Katrina. Today I'm going to talk about some joint work with Sumega Garg at Princeton and Omer, my advisor, which studies fairness in prediction tasks from an information theoretic perspective. Thank you. Great. So I know this is officially a privacy workshop. And so even though the majority of my talk will center around fairness, yeah, right. So at the end, I'll give some musings on how our conclusions sort of interact with privacy, both differential privacy and beyond. I have a lot of slides, and I expect to get through a very small fraction of them. So please interrupt if you have questions. Great. So issues of fairness and discrimination in prediction systems have been getting a lot of attention recently, both in the popular press as well as the academic literature. And so there have been many explanations for why discrimination maybe shows up in machine learning models. And there have been maybe even more attempts to fix the problem. But it seems that with every attempt at fixing the problem, somebody else comes along and says, your attempt is completely broken, here's why, and we should do something completely different. And frankly, the state of affairs is pretty overwhelming and confusing right now. And so in this work, we're not going to propose a new definition of fairness, but instead sort of try to take a step back and say, what's really going on here? What are specific ways in which many of the popular notions of fairness can fail? And then we'll try to give some directives on how to fix such failures and prevent them. So at a high level, our setting will involve decision making about individuals. So individuals will show up. Let's say for concreteness, they're showing up and they are applying for a loan from a bank. And so the first thing that will happen is that these individuals will be mapped into a space of risk scores. So they'll be mapped to some estimated probability of, say, the probability that they'll repay the loan if they're given one. And we'll say that the predictor is what maps them to a risk score. And then, based on this risk score, and possibly some auxiliary information, the decision maker, or the bank, has to decide it has to make a binary decision, whether to give them a loan or whether to reject their application. So that's our highest level setting. So throughout the talk, I'm going to be using sort of these risk score histograms. And so they'll be useful for understanding many of the issues going on here. So what's going on in these plots? So these histograms represent the distribution of outputs given by the predictor, given sort of the input distribution. So in particular, on the x-axis, I have a risk score, or an estimated probability of repayment, let's say. And on the y-axis, I have the fraction of individuals from a given population receiving that score. So in red or orange here, I have one population receiving a score of 0.5, and everybody in the population is receiving it. And in the blue population, I have different scores. So throughout, I'm going to assume that these predictions are so-called calibrated. So calibration has a formal definition that hopefully I'll get to later. But you should think of calibration as saying that the predictions mean what they say. That is to say that, for example, amongst the individuals who are receiving score 0.5, about half of them will actually, in reality, repay their loans, and about half of them will default. So I'll pause there. Is sort of these plots will be important. So if there's any confusion about what's going on in these plots, please stop me.
Question of assumption.
Uh-huh.
You assume again fixed. So this doesn't affect reality outside. So they could be repaying their loans.
Yeah, right. So
there's a signaling effect.
good. So we'll think about one time step for now. But there has been other work talking about sort of longer term effects, and we'll discuss some of them here.
Just again, so you basically, probably I'm getting it all wrong. You're basically assuming that the prediction is a fact.
No. So I'm assuming that the prediction is something that let's go back. So I'm assuming that the prediction is the output of an algorithm. So that is factual. It's the output. It doesn't mean that it represents reality very faithfully. I'm making a mild assumption about the degree to which it represents reality. Yeah. We'll see sort of I'll spoil the main point that assuming that these predictions are fact can be incredibly problematic. And sort of that is one of the points of one of the conclusions. And so we'll discuss the ways in which sort of the informativeness of these predictions actually impacts the long-term decision making.
Okay, so the term calibrated, what are you calibrating?
Good. So what I mean is that sort of when the prediction says 0.5, about half of the people who receive that score actually will repay and will not repay.
That sounds like you're taking the prediction for a fact, or am I saying something stupid?
So no, it's a subtle distinction. So alternatively, I could take these 0.5 people, and potentially, maybe it isn't uniform across the group that they all have a 50% chance. Maybe there are half of the people really are very clearly going to repay, and half are really clearly going to not repay.
Oh, okay.
So that is the distinction between reality and the prediction.
You can also, if it helps, think about the algorithm outputting things that aren't numbers. Like these people are apple, these people are banana. And then you just look at the population and say, oh, 40% of the apple people are, repay the loans. And then just change the name apple to 0.4. In a sense. Think
Sure.
about the word
It's
apple.
about a distribution issue, actually. Yeah.
And we'll see this issue. It's going to show up on the next slide.
Are you allowing random classifiers, random histograms, and if so, are they taken into the probability space? Like you're doing probability over something. Is it just X drawn from the population, or
Yes.
also the rule of the...
Let's assume for the sake of argument that today that the predictor is a deterministic map from inputs to outputs, and the probability that I'm taking is just over the population distribution. Good. So, okay, at sort of a bird's eye view, abstractly, what we would love to do is ensure that the decision maker treats all groups in our population fairly. And so we'll see on the next few slides that even understanding what that means is very complicated and much trickier than it might sound. And it's difficult. And we don't have good answers for that yet. But so for this warm-up example, I want to simplify things a ton. I want to assume that there's two sets of people in the world. There are the graduate students and there are the tech workers, S and T. And I want to make sure that I'm treating these two groups fairly. And further, I'm going to assume, again, for the sake of simplicity, that these populations, in their ability to repay loans, are incredibly similar. They're identically distributed, and in both populations, about half the people will repay their loans, and about half of them will default. So that is to say that the probability of y equals 1 equals 0.5 in both populations. That's the reality. So where am I going to complicate things? I'm going to complicate things in these predictions. Exactly this issue that we were discussing. So I required that the predictions are calibrated, But I didn't say anything more than that. So let's look at these two populations. In S, I'm going to assume that there's a constant prediction that just gives out the sort of mean probability, the average probability across the entire group. And so again, amongst the individuals who receive this score 0.5, about half of them will repay and half of them will default. So that satisfies our notion of calibration. However, this score gives us no information that we didn't already know about an individual. So when I see an individual score, I learn nothing more than I did than just knowing that they were in S already. And in T, I'm going to assume that there is some variability, that actually there is some signal. So in T, I'll say that basically half the people get score 0.75, half get score 0.25. And again, because I've assumed calibration, this means that these distinctions really represent true signal. I actually know that if somebody is in this group, on average at least, they have a higher likelihood of repaying their loan. Good. So is the setup clear? I'm simplifying things greatly, but we'll see that it still results in some interesting issues. Yeah?
Maybe you don't want to say, but like, is like a reason this could be true is that like the features you're using are just. Yeah.
Great, absolutely. No, so I think this is a great point. That this is sort of taken to the extreme, but I think it's a very reasonable assumption that in practice, and people have sort of pointed to this as a source of discrimination in these systems, that somehow you are not adequately modeling different populations, and that the features or that your computational resources that you're investing into making predictions about these populations are not adequately similar or expressive. Good. So one of the first approaches you might think would achieve a certain notion of fairness would be to set a group-independent threshold or a group-independent decision-making policy. So this would try to aim at getting at some sort of meritocratic fairness where ideally individuals would be sort of selected or not selected, similarly based on their similarity in their ability to repay the loan, right? But we'll see that sort of when you use predicted risk scores, the best you can hope for is that, that you select individuals similarly based on their prediction. And this can lead to issues. So for instance, suppose the bank is willing to accept and give out a loan if there's at least a 60% chance that individuals will repay. So that means they're going to set a sort of fixed threshold at about 0.6. And lo and behold, in this example, this leads to the fact that only individuals from this group T will be selected. And why is that? Because no one in S received a score greater than 0.6. And this occurs even though, remember, that we assumed that these populations were distributed identically. So these populations are very similar in their ability to repay loans, yet we're seeing huge disparities in the selection rates. About half of the individuals in T are selected and none are selected in S. And so from the perspective of these populations being similarly distributed, this seems blatantly unfair. So maybe we have to go back to the drawing board. And so a very different approach to fairness that has been studied extensively is the notion of so-called demographic or statistical parity. Yes?
So it seems like you're not allowing yourself to say that the predictor algorithm is the thing that's unfair. It seems like you want...
Yeah, I will allow myself to say that in about 3 slides, yeah. Yeah. But others have not allowed themselves to say that thus far. Right, so good. Good, so this notion of demographic parity or statistical parity aims to equalize the selection rates. And it's one of the sort of main well-studied notions of parity in selection. There's many others, but this is a simple one to start. So in particular, we'll require that explicitly that our selection rule selects the same fraction of people in both populations. So suppose again that the bank suppose that T is sort of the majority population. They're going to dominate the utility or the revenue for the bank. And so the bank will set a threshold accordingly for this population T. Let's say, again, they set a threshold at about 0.6. So this means that they've selected half of the population of T. And these individuals have about a 75% chance of repaying their loans. But again, because we've set our selection rate to be 0.5, that means we have to select half of the individuals in S. But again, we have no information about S, right? Our score has told us nothing about who are the individuals likely or unlikely to repay their loans. So at best, the bank can select a random subset of the population S. And so what does this mean? This leads to big differences in a number of key quantities that people in the fairness and just prediction literature like to track. The true positive rate, the false positive rate, the positive predictive value. If you don't know what these terms mean, it's not too important. But basically, these are all indicators of the quality of your selection rule. And basically, all of these quantities are better in T than in S. Another issue is that the utility decreases for the lender. The bank isn't going to be very happy if you tell them that they have to take a huge hit. And further, some recent work by Liu et al. Has actually argued that this type of selection policy can cause further harm to the minority populations that this sort of parity notion is designed to protect. And this gets back to the idea of sort of things being in a feedback loop. In particular, the argument goes at a high level that as you push this selection threshold down in the minority population, you end up selecting people who have a higher risk of defaulting, which increases the default rate, which then makes the bank less likely to want to lend to them in the future. And so issues of sort of these delayed impact and feedback loops are huge, but already we see that there's issues in a single time step. Good. So any questions at this point? Yeah.
Just about this. So clearly a random selection is not as efficient as selecting based on greater information, but wouldn't you assume that this would be reflected in the interest rate? So
I'm sorry, yeah, I don't understand the question.
The whole idea of risk assessment is that you aggregate risk and then lump risks together and then distribute the risks across society in a way to offset. So the bank actually would be indifferent. The bank will just say interest rates are going to be slightly higher to account for the risk. Because there is the risk because I randomly select.
But so you're speaking a slightly different language than the one that I speak, but I think if I can guess, the point would be that the interest rates would be less desirable in the population S than in T. And this is a consequence not of S's inherent ability to repay their loans, but a consequence of your suboptimal reflection of reality in your predictions.
You're paying higher interest rates because you have less information. That's correct.
S is paying higher interest rates.
S is actually paying lower. T will be paying
lower.
But that's fine.
Better or worse? S is paying worse, is getting worse treatment? I can't imagine. I cannot imagine that.
It would be higher interest rate to offset the uncertainty. So,
That's right. That's the notion. Higher T would actually be paying the price. Why? Because the bank would otherwise lend to T at lower interest rates. Now the bank has to lump the losses in S on T. So
I think I understand.
that's the response usually under fairness, is that when you lump.
Right. I think I understand. Let's take it offline. But I guess the point that I would make is that if we're viewing the job of the bank as estimating risk, somehow somebody is paying the burden for their inability to distinguish in S. And so the question is sort of what happens if we improve things? Frauke?
It's okay, I can hold it.
Okay.
Come back.
Good. So thus far, the fairness on, the literature in fairness has resisted some sort of universal definition of fairness. And we can argue about sort of the universality of differential privacy, but at least in some very specific contexts, differential privacy provides a really strong and really compelling notion of privacy protections. And thus far, sort of most, if not all of the notions presented in the fairness literature have some issues that people have pointed to that feel insurmountable. Sort of a lot of the critiques end up saying something along the lines that under your fairness constraints, you end up selecting the wrong set of individuals. And so I want to pause, though, and sort of go to Beau's point that, like, let's imagine a case where we actually had perfect predictions, where we had great information about all of our population. Well, under perfect predictions, this has been observed in a lot of the literature, actually that many issues disappear. So for instance, in our very toy example in this talk, basically notions of group-independent thresholding and demographic parity will do exactly the same thing in this scenario where the two populations are identically distributed and you have perfect information about them. And so the question then sort of is to ask, what about better predictions for some notion of better? Does that buy you anything? And so the main result in our paper that I'll present as a theorem in quotes here is that basically improving information content for a specific notion of information content in your predictions actually improves the downstream fair selection rule across a wide collection of sort of quantities that both the bank and the individuals would care about. And so one way to interpret our theorem is to say that at times the perceived cost of fairness is really not a cost due to the fairness desiderata that you've stated, as much as due to an information disparity across populations. That if you had good information about all of your populations, then the cost would be offset. That there wouldn't really be a cost to enforcing these fairness goals. And another takeaway is that getting your hands on highly informative, calibrated predictions is important, even if the goal of sort of fairness at the end of the day is parity-based. And so, right, this interpretation pushes back against one of the main notions, or a concept that has been sort of stated, in my opinion, overstated in the fairness literature, that says like accuracy and parity are inherently at odds. I want to basically replace that thought in your mind with sort of refined predictions that allow for improved, sort of more information, give you improved utility, impact, disparity, which all have formal definitions that I didn't really have time to get into. So some takeaways. I think as we've sort of discussed, information disparity can arise across populations for many different reasons. And it's important when you have a risk score predictor to audit these scores for their information content. In our paper, we give some sort of formal tools for doing this. I'll speak at a high level here. But sort of concretely, it would be interesting to look at, say, credit scores that are used in practice and understand sort of, can you demonstrate that empirically the risk scores in some populations are less informative than in others? And if so, then that means you need to either invest more computational effort or collect better features. Then another key takeaway is for us as researchers. When we're designing and critiquing fairness notions, we need to ask ourselves, what set of assumptions does my notion explicitly or implicitly make? Solon has a great paper sort of making this point very clear that every notion of fairness makes some underlying assumptions about your populations. What are they? And let's state them more clearly. Let's state them explicitly up front so that we can reason about them. The next point is sort of that a question to ask is, are my requirements for fairness robust in a certain sense to information disparity? That is to say that sort of when you're stating a fairness desideratum, like make sure it's exactly what you mean. And once you have that goal, like let's say it's to increase representation in the minority population. That's not the same thing as mathematically as saying, I want statistical parity, right? So let's make sure that we faithfully translate these sort of notions into mathematical constraints and understand what the consequence of requiring these constraints would be if we have less information in one population versus another. And then finally, I think it's important to ask ourselves when we're critiquing notions, when we come up with something that we don't like about a fairness notion, ask ourselves, am I exploiting sort of the true sort of principled approach to fairness here, or am I exploiting disparity in information across my population? And it's important to understand, I'm not saying that exploiting information disparity isn't a reasonable thing to do. I'm just saying to disambiguate these things and critique what you really mean to critique. Yeah, Adam.
I have a question. So you're using information as the key concept here, and it feels like what you're using, like you could replace accuracy kind of everywhere in this slide, right? And it feels like So formally, I didn't have time to talk about this, and I tailored this talk to be more high level. But what I mean by information has a formal definition in the context of calibrated predictors, and it is closely tied to, let's say, squared error, or likelihood, or some variance. Exactly, yeah. Right. So is there a reason why the information is the relevant concept here?
I think the distinction is that it's important to reason about these things with calibration. And this notion, once you fix things to be calibrated, then these notions of like accuracy with respect to, say, squared error, variance, these kinds of things, and information are basically equivalent. So like, yes, accuracy and information are sort of the same thing here.
For instance, maybe as a follow-up to Adam's question, is the information that you need in order to get this accuracy, is that compatible with what you could get from essentially private computations?
Great question. So yes, absolutely. So when I say information, like I'm saying sort of your ability to make reasonable predictions about the population that you haven't observed. If there is a simple rule, or if there is maybe not even a simple rule, if there is a rule for predicting y given x that I can learn from the population, then largely I should be able to do this in a differentially private manner. I should be able to collect aggregate statistics and incorporate these statistics into my predictions. And we even do this in the paper. And in another paper, we show that it's compatible with differential privacy. It's not too hard to see. So in a sense, this does give you a way to sort of learn simultaneously fair and private predictions. But then sort of to say something maybe a little bit more controversial in this beyond differential privacy workshop, I think a question to ask yourself is sort of, is the notion of differential privacy what we really want here? I've been arguing that your ability to make predictions across populations very accurately or informatively is essential to fairness. But maybe that means collecting more data. Maybe that means me being able to make a prediction about you, even if I've never seen you before.
And is that a solution that we feel comfortable with? And so I think thinking about information is important here. Who's using the information? What are they using it for? And for people who know more about this than me, I would love to hear your thoughts if contextual integrity or something along these lines makes sense here. So I'll stop there for now and take any questions. Yeah.
This is great. Just two quick things. So like one is that there's like a pretty well thought through like trade-off between fairness in the sense of non-discrimination and privacy. So there's an excellent paper from like maybe 10 years ago that makes this exact point, right?
Cool.
Which is like the way you would solve this type of problem is by going off to collect more information, but that itself then raises privacy concerns, and I'd be happy to share that. And like economists have thought about this as well.
Yeah.
The other question I was going to ask though is that from like a legal perspective, what's often interested me, and this is something that Jamie maybe was the first person to bring to my attention, was that an argument against doing this, like spending money to go collect additional features, is cost. And sometimes you can actually justify like the fact that your decision-making process results in discrimination by saying that the additional cost that I would incur to collect necessary informative features is so substantial that it's like impractical. And there's actual like cases that are decided about this, right? Like we can't compel people to take on some burden that would basically run the business into the ground, right? So I'm kind of interested how some of this work also might feed into like legal arguments about like, well, can we sort of think about the degree to which we want to say, no, actually, you have to incur this cost, or like this is such a ridiculous kind of like uneven way of making decisions that like even if, you know, the cost is substantial, like we're going to still assert that you do this. And I actually think Jamie made the most interesting point, which is that she was pointing out to me at this event, like if cost ends up being a justification for not doing this, like the decision maker gets to set the baseline by just choosing to have like a bad decision-making process in the first place.
And saying it's expensive to do something better.
Yeah.
And like, I guess I don't know the formal trade-off in terms of expense because I don't understand law particularly well. But it is interesting.
I mean, I've learned a little bit since since this interaction with Jamie, which is that like there's a sort of like you make reference to what is common practice among your peers, right? So if like everyone else in your industry is doing this, even though like that means there's like manifest disparate impact or something, that's okay, right? And a very clear example of this is like we have like thin credit files or credit invisible, people like where we just don't have very much information, and like that clearly has a disparate impact, right? Like the people who are not well represented in credit files tend to be disproportionately members of protected classes, and we still say like that's okay. We're not going to force the people to go spend money to collect information, and somehow that's reasonable because that's common practice across the industry.
Yeah, I think what's interesting here is that this notion of information, it's something that we've given a little bit of thought to, not from the same perspective, but this notion of information is something that like the bank would benefit from anyway, right? Like
if it were free, if it were free.
No, sure. I'm saying like if I gave this to you for free, you know, and you got to predict for the future forever and ever, like it would be in your interest to have this information.
If you expect it will translate into like a return of some sort, but like if the return that you predict you'll get is like very small, which it might be for these.
No, yeah, I'm saying so I can argue formally that sort of if this information were given to you for free, you should take it, and you can always simulate the decisions that you wanted, you know, that you had without this information, even if you're given the information. I can throw it out. So it can't hurt you. And so the question is sort of, I mean, I think it's a super interesting point, and it's one that we've thought about from, theoretical computer science perspective, but not further.
One perspective is that perhaps we shouldn't allow personalization beyond some level of information. So the moment you open your computer, a new computer, they know very little about you and immediately start personalizing to you. And this work or other approaches can give a very concrete value. And we can say, we can have a regulation saying that if your informativeness on sensitive
communities is below some threshold, some fixed threshold, then personalization should just not be allowed, because personalization at that point of not knowing is just being based on it's just a definition of discrimination, it's a definition of bias and stereotypes, right? A discrimination based on very little information is a stereotype. So this could translate to, yeah, you don't want to gather information, but don't personalize.
Right. I think our point was just that, like, it's interesting to think about this in terms of, like, the legal arguments that come from information never being free. Yeah.
Do you want to ask a question? Because I'm just going to make an announcement.
Very good. So maybe a question is unfair depending on the definition of fairness. But it's about the relationship between risk and trust. So, sorry. You assume that the risk is embodied in the score is somehow neutral. It doesn't raise in and of itself fairness concerns. So you assume that the distribution of the ability to return the loan is exogenous in the sense that we don't ask fairness questions about that. This is just given by the market, nature, society, some exogenous, and part of the problem. So if we shift from the market to health, just to give an example, right? We would not necessarily say that people with higher risks to some diseases which is genetic, should therefore necessarily pay higher insurance. We will say, maybe we're not going to ask this,
Right.
because we don't trust, right? Because we think that there may be some economic reasons why the HMOs or other insurance will say, well, we do want to tax you for your genetic disease, so we want to reach a more efficient way, and that would mean that if you were born a certain way, then life is just going to be more expensive for you. Tough luck, that's nature. Sorry. We somehow would think, I think, that this is unfair because of the distribution of risk. So to the extent that you include distribution of risks endogenously in the model, I think you might get a different result with respect to sensitivity to information.
It's an interesting point, right? So I think our assumptions, or the work lies at a level of abstraction that isn't modeling these kinds of concerns, and it is sort of assuming a trustworthy decision maker who's doing things in the best interest. But we should talk about it offline.
Yeah, there are many more questions and points to be raised, but yeah, let's quick announcement.
Yeah. So they're going to be co-located workshops, for lack of a better word right now. It's not just workshops with ACM FAT this coming year, and it's called Critiquing and Revisiting all of the FAT stuff, craft. And this would be like a perfect workshop to bring in people from different backgrounds who want to look at this question and criticize very